Dear all, it is my pleasure to be with you again. And we will discuss here about gases. If you look here to the someone is diving, here someone going to the space. So chemistry is our life. This is the application of what? If someone diving, he need a gas, otherwise he will die immediately. Now, there is a very big development of people go to the space. How to do that without gases? So therefore, we must understand what is the definition, what properties and laws, right? So let us try to understand how much this is importance of substances exist as a gas. What is the pressure, which is main factor of gases? What about the laws, which we can use it for calculations? What about ideal gas equation? So if we look to the substances exist as a gases, the, the air, how much it contains? About 78% nitrogen, 21% oxygen, 1% of gases included carbon dioxide. More than 30 years ago, it was discussed about the chemistry of this fatal mixture of gases becomes a source of great interest. Why? Because it determines the effect of environmental pollution. Now, it is a global international problem about pollution, which affect on climate changes. This is a big problem suffering all over the world. And they would like to invest huge billions of dollars in order to solve the problem. They realize it now. However, it started more than 30 years ago. So you see how much chemistry is important in our life, right? It is really very huge money to solve the problem. Now you can see also how much temperature has been changed a lot. What about the fires has been in Europe during last summer, also in some countries in Africa. This is new factors affecting all over the world about gases and air pollutions. Therefore, we will focus also about the behavior of substances that exist in gases, which under normal atmospheric conditions, of course, at room temperature, and 1 atmosphere, ATM. So this is the unit, ATM, about atmospheric pressure. We have how many elements as gases? 11 elements, right? As you can see here, elements exist as gases. And therefore, classification of gases, it can be fill container. In previous time, we buy cylinder to use the gas for cooking at our home. Now, many countries have substituted with tubes of gases, right? This for it is random, no attraction. Gases are fluids like liquids, so no attraction. Gases also have very low densities. That's why you can see a lot of empty spaces. It can be compressed, right? It means no volume, lots of empty space. And this is how you can see if it is compressed. That's why if you have cylinder of gas and it is open, then you have just a fire. It can explode and make a very big, serious problems of fire. Why? Because it is compressed gas in such a cylinder. This is how you can see here. And another picture, another definition when it has a lot of empty space. So you see, chemistry is understandable when you show it by figure and when you correlate it with our daily life, right? What about gases undergo diffusion and effusion? What is the meaning of diffusion and effusion? If you look to the figures first, then you can understand what is the difference between this and that one. You see, Here is the distance, very small. Here is compressed. If you understand this about motion, this you will understand about diffusion. So diffusion is a process by which gas gradually mixes with another, just gradually mixes with another. What about effusion? Process which gas under pressure escapes from one compartment of container to another by passing through a small opening. Here you can see also how it look like, right? So this shows you how the random motion and compressing, right? And if we look to the elements, so gases could be element, right? It can be also compounds, right? So this is different example which showed you both. What about pressure of gas? So gas exert pressure on the surface that which come in contact because gas molecules are constantly in motion. Humans have adapted as so will physiological to be pressure of the air around us. So as we are usually unaware about it, right? We don't feel about it. But if you do like that, how long time you can keep without air? And if someone forced you, after a few minutes you will die. We can correlate it with fish. If you take a fish from water, just outside for a few minutes, the fish will immediately die, right? So this is surrounding, so we sometimes don't feel about it. Units of pressure is one, of course, most readily measurable property of gas. To understand how we measure the pressure of gas, it is helpful to know how the units of the measured are derived. Therefore, we should understand the equations. We'll begin with the velocity and acceleration. What means velocity? What's the equation? Defined as what? Distance with elapsed. So distance moved divided by elapsed time. What about acceleration? Change in velocity divided by elapsed time. M over S2. What about force? Equal mass multiplied by acceleration, which is Newton. Finally, we define pressure as force applied per unit area. So SI, unit of pressure, is Pascal, defined as 1 Newton per square meter. So 1 PA is equal 1 N divided by M2. So here is the first law we'll understand and we apply the equation. What do you expect about pressure? Pressure logically is force and area. How we can express that? Force equal mass multiplied by acceleration, and we'll look to it more in slide 13. But this, again, figure to show you what is the pressure, force and area, right? Atmospheric pressure. To understand atmospheric pressure, some of you at least, had been flying by aeroplane. What you feel, especially when the aeroplane is landing, you feel something in your ear, and you cannot, if you talk with your the one sitting beside you in the aeroplane and you talk to him, it will be difficult to hear each other. Why? Because of the atmospheric pressure. The aeroplane had been in very high and it goes down. So it means that there is direct relationship or inverse relationship we will see together, right? So this example, you see, try to correlate the science with our daily life, right? So the atmosphere is much denser near the surface of the high altitude, right? In fact, the density of air decreases very rapidly, so air decrease with increasing inverse relationship. So the measurement showed, for example, 6.5 kilometer on the surface is about 90%, 50%, increases to 90% of 16 kilometer, and 99% within 32 kilometer. Explains also that some people have gum when they fly, right? So the atmospheric pressure is the pressure exerted by the Earth's atmosphere. So it depending on the Earth's atmosphere. The actual volume value of atmospheric pressure depends on location, temperature, and weather conditions, right? That's why, again, if there is a problem on the weather, the flight usually delay, or sometimes cannot land if there is weather problems. So this is the most important factors, right? And the barometer, what's the barometer? This is how we measure atmospheric pressure. So it is an instrument. Let us see it by another way. Look to such picture, and then you will understand more how the volume affects atmospheric pressure, right? Look to this. And here is the atmospheric pressure, right? What about this? Here, one distance, one distance, one distance. What do you expect when increasing and decreasing pressure? Look at by value here, right? Sea level. What about when it is in the sea level? 1 atom. What about if it increase 4 miles? It will be decrease the pressure. What about if increase mile again? The pressure will be decreases again. 10 miles, what do you expect? It will be decreasing again to 0.2. You see, chemistry is fun when you understand it. What about the barometer, which measures atmospheric pressure? It depends on what? It depends on the atmospheric pressure. One atom, an atmospheric, is equal 760 mm, or 76 centimeter, equal to 760 mmHg. So 706 meter here, centimeter, is equal to 760 mm or Hg. So the barometer here for measuring atmospheric pressure. What about for mmHg? This is the unit attributed to the Italian guy who discovered it. Therefore, one tour is equal 1 mmHg. And we already said that one atmospheric is equal 760 mm, which is equal 760 mmHg. So that's why one atom is equal both, right? Therefore, relation between atmosphere and pascals, one atmospheric is equal this value. And then one atmospheric will be equal this value here, right? So another example to show you, I think you will understand it now by yourself, right? How much distance affect. Here is 0.7. Here, longer distance than one atmospheric, right? So the manometer is device used to measure the pressure of gases, which is very important factor, as I told you by examples other than atmosphere. And the atmospheric pressure submit to Daniele was 606 mmHg on certain day. What about the pressure in atmospheric? So we have 4 laws And these four laws will control about the gas. So we know the law, and then you practice examples. And please, when you work with examples and you solve problems, try to work with a team. Then it's good for you. Again, we will look to the picture before we read, and then we try to understand. What is the difference here? There are two balloons, right? What's the difference between two balloons? This one is big and this is smaller, right? What is the factor here? Temperature. What do you expect? Yes, here should be temperature lower than this one. That's why it affects the volume. So it means that if it is constant temperature, it will be a constant amount of gas. What about if volume will be inversely proportional to pressure, right? So this is the first law about pressure and volume relationship. So here is 25 degrees centigrade, but here is minus 5 degrees centigrade. If we look to this figure, this is P1 V1. What do you expect? Will equal B2 V2, right? From this diagram. We can practice one example here. A sample of chlorine gas occupies volume of 946 milli. So this is a volume at pressure of 726. This is a pressure mmHg. What is the pressure of the gas in mmHg if the volume is reduced at constant temperature of to 154 milli, right? I think you will apply the BV equal constant. It means B1 V1 equal B2 V2, as we said before. You have P1 already, as we said. You have V1, you have V2, then you need B2. So we'll have the equation B2 is equal B1 multiplied by V1 divided by V2. Then you put the values, then you will get the final, right? Then the other one, Charles' law. What's the difference between both? Right? Yes. This is a temperature volume relationship. It means volume is directly proportional to temperature. What do you think here? Look to the two tubes. How you can explain that? Right. So here is low temperature. Right. Then the gas is this amount. What about high temperature? Look to the gas expanded until here. Here, of course, is mercury, and this is capillary tubing. Here, you can see. So gas expanded and contracting according to the temperature, as we have said. Of course, at constant pressure. So as T increases, then volume increases. What about Charles' law? It means that V directly proportional to temperature. So V will equal constant multiplied by temperature. This is the usual. So V1 divided by T1 equal V2 divided by T2. Temperature must be in Kelvin. You know that. So this is Charles' law, and this is a temperature here, and this is a T2 here. Of course, at constant pressure, as we have said. And this is volume equal 1, where here, of course, the volume is higher, so it is equal to, right? So again, one example to show you this sample of the gas occupies 3.2 liter at 125. At what temperature the gas occupy a volume of 1.5? So we have here 3 values, and the 4th value is we need to conclude it. So it's very easy. V1 divided by T1 equal V2 divided by T2. We have three of them, V1, T1. We have also then the other volume, V2. Then we can V2. Then we need to get T2. So three values we have, and therefore we can get it through equation. Then T1 equal V2 multiplied T1 divided by V1. Then you calculate it to get the T2. So think it's very... Now, another example about the gas law. I think from the picture again, what is the difference here? Look for a second. Cylinder, and here is a temperature 300. Here it is 600. What do you expect about pressure? Temperature here increases from 300 to 600. Then the pressure will be increased from 1 to 2. So temperature is directly proportional to pressure. Therefore, you can have the next law. B1 divided by T1 equal B2 divided by T2. Right? So if you have example and you give the three known, then you can deduct the fourth one. Right? Avogadro's law is volume directly proportional to the number of moles. What do you expect? V equal constant multiplied by n. Now you know it. Then you can even conclude the equation. V1 divided by N1 equal V2 divided by N2. Then if you get example and you have 3 is known, you can conclude number 4. This is here, for example, what's 3 moles of hydrogen. Hydrogen, hydrogen, hydrogen. So if it is 3 moles of hydrogen, it means 3 molecules, 3 moles, 3 volumes. What about nitrogen? 1 mole, 1 molecule, 1 volume. It will give you ammonia, 2 molecules. You see, of course, you know, ammonia is 3 bonds. N here attached to 3 bonds of hydrogen. So 2 moles of ammonia, it means 2 molecules, 2 moles, 2 volumes. So this explains you, and I remind you, carbon must have 4 bonds, nitrogen 3 bonds, oxygen 2 bonds, hydrogen is only 1 bond, as you can see here or here, right? So it means that you will know also this role, this conclude you about Boyle's law, which is B directly is inversely proportional to 1 over V, while Charles' law, V directly proportional to T. Avogadro volume directly proportional to number of molecules. The final one, pressure directly proportional to T. So 3 are directly proportional, while 1 is the opposite, right? That's why all increasing like directly proportional, directly, right? Or the only one is the opposite. Pressure increased, volume decreased, right? So this is the gas laws abbreviation of all of it. Now you can apply to another examples about ammonia burns in oxygen to form nitric oxide and water vapor. How many volumes of nitric oxide are obtained from 1 volume of ammonia at the same temperature and pressure, right? So you put the equation, ammonia plus oxygen equal NO plus water, and of course you make it balance, and this you know it from previous chapter. So 1 moles of ammonia will equal 1 mole of NO at constant temperature and pressure. It means 1 volume of ammonia will equal 1 volume of NO. So the ideal gas, we will put the equations B inversely proportional to 1V, Charles' law at constant pressure, Avogadro's law. So all 3 expressions above can combine to form a single master equation for the behavior of gases. This is very important. it will be the three all equations will combine to form master equation, right? It means V will be directly proportional to NT divided by B. Therefore, V will be equal constant multiplied by NT over B. So this will equal R NT over B. R, of course, is the gas constant. So BV will equal nRT. If you take an example about the container has 1 atmospheric are called standard temperature and pressure STP. For any gas, experiments show that as STP, right? So 1 mole of ideal gas occupies 22.4 liter. So we apply the equation BV equal nRT as we said. This will equal 1 atom of 22 divided by 1 multiplied by 273. Then we will get the value. What about another example? Volume in milliliter occupies 63.7 of HCl. Then we use the same equation. We got the temperature already here and the pressure 1 atmospheric. Then we will apply the equation we have said before. This means that 63.7 of the HCl, right, multiplied 1 mole of HCl divided by 36, which is, chlorine is, and the hydrogen is 36 gram of HCl. This will be 1.75 volume. So then you apply the equation. We will practice, of course, with some examples like that. And please, when you work with such equations, try to work in groups. This is very important for you as a teamwork. Then you use the calculator to get the final. What about the volume occupied by 49.8 of HCl? Then again, the same equation. Then you apply with such new amount to get the volume at the end, right? And of course, you remember that HCl is 36.4. This is how you work with examples. I hope it will be useful for you, and please practice on such equation and use the final master equation. I hope you have enjoyed the lecture and you understand more how much is chemistry important for our daily life. And the development in chemistry, especially people go to the space, and also the ideas they design about they use for designing airplanes, and the development in this area also you could correlate it with the people died in when they go for long diving recently in United States. Thank you very much for listening, and please put your constructive criticism and work in groups for solving equations. See you again. Bye bye. يا رب يجعله علما نافعا يا رب.